Welcome to Learn with us. This is the seventh practical of basic electronics.
The first objective of this practical is to identify diode schematic symbols, and the second objective is to describe forward biased and reverse biased operating characteristics of diode. Now, what is a diode? A semiconductor diode is a two-terminal electronic component with a p-n junction. It is also called a rectifier. A semiconductor diode is formed by doping p-type impurity on one side and n-type impurity on another side of the semiconductor crystal, forming a p-n junction. At this p-n junction, free charge carriers, that is electrons, and holes from both sides, they recombine, forming negatively charged ions on p side of the junction and positively charged ions on n side of the junction. As a result, depletion region is formed. This depletion region does not contain any type of free charge carrier. Now look at this figure. As you can see here, depletion region is formed between p side and n side of this semiconductor diode. Further recombination of free charge carriers from both sides is now prevented because of the depletion voltage, which is generated due to charge carriers that are kept at a distance by depletion. It means here this depletion region acts like an insulation layer. Okay. Now we will talk about symbol of a diode. A diode has two terminals, anode and cathode. The anode, which is the positive terminal of a diode, it is represented with A, and the cathode, which is the negative terminal, it is represented with K. Now what about practical diodes? In case of a practical diode, a fine line is drawn on the diode, which means cathode, while the other end represents anode. Now look at this figure. This is how a practical diode looks. As you can see here, a fine line is drawn which is representing cathode, while the other end is anode. So this is how you are going to identify terminals of a practical diode. Now we will understand working principle of a diode. When voltage is not applied across a diode, depletion region is formed, and when the voltage is applied between the two terminals of the diode, two possibilities arise depending on the polarity of DC supply or battery. First is forward biased condition and second is reverse biased condition. Now look at this figure. This kind of connection is said to be forward biased condition. Here, as you can see, positive terminal of the diode is connected to the positive terminal of the battery or supply, and negative terminal of the diode is connected to the negative terminal of the battery or supply. This kind of connection helps in more conduction. It means a diode conducts well in forward biased condition. Now look at this figure. This kind of connection is said to be reverse biased condition, where positive terminal of the diode is connected to the negative terminal of the battery or supply, and negative terminal of the diode is connected to the positive terminal of the battery or supply. This kind of connection helps in minimizing and preventing the conduction. It means a diode cannot conduct in reverse biased condition. In short, current flows through diode in forward biased condition and it does not flow through diode in reverse biased condition. A diode can pass current in one direction only. So this is the working principle of diode. Now we will understand current voltage characteristic curve of a diode. Look at this graph. It shows the state of diode conduction in forward and reverse biased conditions. During the operation, when the diode is in forward biased condition, at some voltage, the potential barrier gets eliminated. Such a voltage is called cutoff voltage or knee voltage. If the forward voltage exceeds beyond the limit, the forward current rises exponentially, and if this is done further, the device is damaged due to overheating. Now look at this graph and look at point A. If you draw a line from this point A on x-axis, then you will get the value of cutoff voltage or knee voltage. Okay. Now what about reverse bias conditions? During the reverse biased condition, current produced through minority carriers exist, which is known as reverse current. As the reverse voltage increases, this reverse current also increases and it suddenly breaks down at a point, resulting in the permanent destruction of the junction. So this is the current voltage characteristic curve of a diode. Now here is your lab activity. First you have to build this circuit on a breadboard. As you can see, this is a forward biased connection because here positive terminal of this battery is connected to the positive terminal of this diode. Okay. After that, connect the voltmeter in parallel to this diode. Then connect the ammeter in series with diode. You can also use two multimeters, one for measuring current through diode and second for measuring voltage across diode. Then connect the power supply and increase the voltage from 0 volts to 15 volts in steps. Then measure the voltage across diode and current through diode. Note down the readings in the observation table. Then plot the graph between current and voltage that you have measured. Then you have to repeat this activity for reverse biased condition. It means you have to change the position of this diode. It means now positive terminal of the supply, it will be connected to the negative terminal of this diode. Okay. So this is your lab activity. Now here we have your post lab task. Your first question is, what is the diode current equation? The second question is, what is the effect of temperature on p-n junction diodes? And the third question is, what are the applications of a p-n junction diode? You have to answer all these questions. Okay.
Thank you for watching this video. If you have any questions, then write your questions in comment section of this video. Don't forget to subscribe our channel and share it with your friends and family. Thank you.